5.1 Graphing exponential functions. Okay, so we're just going to go through some exponential functions and typing it into your calculator. So your calculator should have a button like this, or y to the power of x, or x to the power of y, or an x with a box right there. But what I want you to do right now is I want you to pause this video and I want you to fill in all of these table of values. So pause it and fill in all of the table of values given. Okay, so this is what you should have gotten. And let's just do some quick sketch, or let's see if there's anything we find that's in common. So first of all, these points right here, 0 and 1, 0 and 2, 0 and 1, 0 and 8, those are important because they are our y-intercepts. And what you should notice that's common about them, if we call this equation y equals a times b to the power of x, or whatever, c, it says c there, shoot. Our c value is going to tell us what our intercept is. So for this one, there's nothing there, so it's a 1. This one, it's 2, which is what our intercept is. This one is 1, which is what our intercept is. This one is 8, which is what our intercept is. So our intercept is determined by that c value. The part in the brackets is what is called the base. So the base of that exponent, and it determines whether it's increasing or decreasing. So what you should have noticed is that this one is increasing. It's starting little and it's getting bigger. That's called exponential growth. Second one is also increasing. And what determines it is this 10 and this 5. The next two start big and get small, so they are decreasing, which is called exponential decay. And the reason why they are decaying is because this b value is between 0 and 1. So it's a decimal between 0 and 1. To graph these, we could plot the points, but really all I need to see is the y-intercept, and then if it's increasing or decreasing. So for the first one, it would look like this. The second one has a y-intercept at 2, and it is increasing. So it looks like this. The next one has a y-intercept at 1, and it is decreasing. This one we probably could graph because there's more points, but it would look like this. And the last one has a y-intercept of 8, and then it is decreasing. Oops. So really, for those sketches right there, I mostly just need to see the intercept and if it's increasing and decreasing. I mean, you could get more technical. We have the points. We might as well. So 1 is going to hit 2. So this one would decrease a lot faster than what I even put. So it would look more like that. And the domain for all of these is x is an element of the real numbers. And the range for all of these is greater than or equal to 0. So that's kind of our basic exponential functions. We can tell if data is exponential by doing a ratio of our y values. So what I'm going to do is I'm going to divide. So I'm going to go 1.25 and divide it by the previous number. And what I get is 2. And I could do 2.5 divided by 1.25 to get 2. And then 5 divided by 2.5 is 2. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So because those all have the same ratio, my base is going to be 2. I also can see that my y-intercept is at 5. So I could easily make this equation to be 5 times 2 to the power of x. And the last one, we're going to graph y equals 1 over 3 to the power of x. Determine the effect on y when x increases by 1. If it's increasing and decreasing, the intercepts equation of any asymptotes, domain, and range. Okay, so first of all, my y-intercept is 1 because there's nothing in front of the brackets. The way that y and x are affected is by that ratio. The base is 1/3, which means that it is decreasing because it is between 0 and 1, which means it's going to go from quadrant 2 to quadrant 1 and then decrease. We don't have any vertical asymptotes, but we will have a horizontal asymptote at y equals 0. It doesn't actually ever touch that axis. Our domain is going to be all the real numbers. Our range is going to be greater than 0. Not equal to. Oops. And our x-intercept, we don't have one, so it's none, because it's never going to touch that x-axis. So to graph this, I'm going to plot a point at my y-intercept at 1, and then it would be decreasing. We could make it a little bit more accurate, though. If we plug a -2 and -1, 0, 1, 2 in. Remember how our exponent laws work, that a negative is just, you do the reciprocal and then raise it to that power. So if I did 1 over 3 to the power of -2, it's the same as 3 over 1 squared. So it's 9. This one would be 3. This one would be 1. This would be 1/3. This would be 1/9. Okay, so we could go to -2 and 9, -1 and 3, and that's a little bit more accurate. So if you don't remember your exponent laws, we're going to go through them a little bit more in depth after. But this is just a quick little intro into exponential functions. What I want you to do is I want you to become more familiar with them, and I want you to go do the math lab on, I don't even know what page it's on, 343. Go do that. Okay, bye!